Hi, my name is Manuel Baum and I would like to present our paper, The World is its Own Best Model, Robust Real-World Manipulation through Online Behavior Selection. This paper is about generating behavior robust to disturbances, and one of our two example tasks is a robot trying to open a drawer. While the robot tries to perform its task, we significantly disturb it, for example by pushing against the end effector, and we keep the drawer shut while the robot tries to open it. But as you will see, the robot successfully recovers from this failure and fulfills its task. Now the question is, do robots have to explicitly anticipate all the disturbances that may happen during task execution, or can they get by just using feedback? This paper is a little bit non-standard in the way that we do not propose a new method to increase robustness, but rather we suggest to increase robustness by not doing something that we as roboticists have been doing for a long while. Now, when we generate behavior like this, we may consider the states in this task. For example, while the robot is in free space, we may want to execute a controller that makes contact with the drawer. Then, another controller slides down towards the handle, yet another controller grasps the handle, and finally we pull open the drawer. A linear sequence like this may be the outcome of design, automated planning, or also learning from demonstration. And the problem with a linear sequence like this is that this is not going to work when there are severe disturbances. For example, a failed grasp attempt may require the robot to jump back in the sequence to execute a controller that makes contact again. We may try to make this structure more robust by expanding this linear sequence into a tree-like contingency plan that tries to anticipate all the possible disturbances that may occur. But the problem with this approach is that the tree quickly becomes very complex, and again, this is not going to work when not all contingencies could be anticipated. This is why we suggest not to try to explicitly anticipate and represent disturbances, but to use feedback from the environment to decide which controller to execute on the fly. When we do that properly, we can in each moment decide which controller should be executed. Then, as the environment transitions through different states, we can always select that controller which is appropriate for the current state. This makes behavior robust not only to low-level disturbances, but also to severe disturbances that significantly change the task's high-level state. We reactively generate an appropriate sequence of controllers without planning. Other approaches than ours also use this idea, but we concentrate on showing how even a very simple system can become robust by abstaining from task temporal assumptions. Okay, but this sounds a little bit too good to be true. We make behavior more simple and we become more robust at the same time. This certainly can work for all tasks. It just works for tasks without perceptual aliasing. So tasks where multiple states do not yield the same sensor input. But we want to convince you that this set is larger than we usually think it is. Because typical manipulation settings offer rich sensor context due to diverse sensor modalities such as vision, force torque, or tactile. But even more importantly, we can use interactive perception to increase the size of this set. In our case, while these three different states look very similar to the camera that is mounted on the robot's wrist, our controllers exert additional forces that help the robot disambiguate those states. So for example, while we pull open the drawer, we also push down onto the handle, and this helps the robot understand that it is still in contact with the drawer. This is an example of interactive perception, where interaction enriches our sensor feedback, which allows us to directly infer the state of the task and to avoid brittle assumptions about task structure. If you think these ideas are interesting, please have a read of our paper and of course be happy to take questions. Thanks.